Assalamualaikum warahmatullahi wabarakatuh. My name is Fitri bin Abdul Rahim. So I will start the presentation with an introduction. In the modern world, advancement in electrical system infrastructure development and environmental management intersect to address both technological and sustainability challenges. This literature review examines 5 significant topics: the application of volume control potentiometers in our system, the mathematical and practical distinction between RMS and peak voltage, the controversies surrounding the Bakun Dam project in Sarawak, the calculation and application of half-cycle average voltage in AC circuit, and the interaction of RMS and DC level in sine wave. Each of these topics provide valuable insight into electrical engineering, signal processing, and environmental policy, drawing from both academic studies and real-world application. The aim of this review is to represent a comprehensive synthesis of these areas, highlighting their interconnected nature and the importance of both theoretical and practical approach in the modern engineering practice. For the next part, I will be presenting a literature review on a key concept in electrical and electronic system, as well as a significant case study. This topic not only deepen our theoretical understanding but also highlight a practical application in our daily life. We will explore volume control potentiometers in audio system, RMS voltage versus peak voltage, the controversy surrounding the Bakun Dam in Sarawak, half-cycle average voltage in circuit, and the interaction of RMS and DC level in sine wave. First, let's discuss volume control potentiometer. These components are essential in audio system, allowing us to adjust loudness by varying the amplitude of electrical signals. Quad Twin 2023 explained how potentiometers manipulate resistance to modulate sound level. There are two main types: linear and logarithmic. Linear potentiometer provide uniform volume changes, while logarithmic ones align with our natural hearing response, creating a smoother sound adjustment. For example, consider the volume knob on a speaker. Its functionality depends on the types of potentiometer used. As Electronics Tech Exchange 2021 notes, proper integration minimizes distortion and ensure high quality sound. Next, we have RMS voltage and peak voltage, two fundamental concepts in AC system. RMS or root mean square voltage represent the effective value of an AC signal, correlating with power delivery. In contrast, peak voltage shows the maximum amplitude of the signal. According to ResearchGate 2021, RMS voltage is critical for accurate power calculation in systems like telecommunication and energy efficient designs. Quad Twin 2023 emphasized its role in precise voltage regulation, making it indispensable for modern electrical engineering. Now, let's shift to the Bakun Dam in Sarawak, a large-scale infrastructure project with significant controversy. The Borneo Project 2021 highlights environmental impacts such as deforestation, biodiversity loss, and greenhouse gas emission from the flood reservoir. Socially, over 10,000 indigenous people were displaced, raising ethical concern. The International Rivers Network 2009 criticized the environmental impact assessment for its gaps, particularly in sedimentation control. Mongabe News 2009 questioned the dam's long-term sustainability, given its ecological and social costs. This case reminds us of the delicate balance between development and environmental preservation. Moving on, we have half-cycle average voltage, crucial for analyzing waveform behavior in AC circuits. Multizen Software Manuals 2021 explain how to calculate these values and validate them through simulation. This is especially important in designing rectifiers and AC-DC converters. For example, Electronics Tech Exchange 2020 discusses how accurate half-cycle voltage calculation, optimized rectifier performance, bridging theoretical analysis with real-world application. This calculation ensure efficient and reliable circuit design. Lastly, let's explore RMS and DC level in sine wave. ResearchGate 2022 illustrate how these calculations are vital for ensuring signal integrity in mixed signal circuits. For instance, in telecommunication and audio processing, minimizing distortion is key. Multizen Software Tutorial 2021 show how engineers use to visualize and analyze this interaction, optimizing design for clarity and efficiency. The interplay of RMS and DC level ensure high performance in circuit handling both AC and DC component. In conclusion, we have explored practical and theoretical aspect of volume control potentiometers. RMS versus peak voltage, the Bakundam controversy, half cycle average voltage, and RMS DC level in sine wave. This topic demonstrates the interplay between engineering, principle, and real world application. That's all from me. I will pass to the next presenter.
Assalamualaikum. My name is Nurdini binti Muhammad Zain. I'm going to start the presentation with discussing question number 1, which is when an electrical signal is converted to sound by a speaker, the loudness of the sound depends on the amplitude of the signal applied to the speaker. Based on this, explain how the volume control potentiometer is used to adjust the loudness volume of the sound. Okay, so a volume control potentiometer is a crucial component in audio systems. Functioning as a variable voltage divider, it has three terminals, one for the input audio signal, one for the output to the speaker, and one connected to ground. When you adjust the potentiometer, it changes the resistance, which in turn alters the amplitude of the audio signal sent to the speaker. At maximum resistance, the full signal reaches the speaker, resulting in loud volume. At minimum resistance, only a minimal signal is sent, producing a quieter sound. The potentiometer functions as a variable resistor, allowing users to change its resistance and thereby control how much of the input signal reaches the speaker. This adjustment creates a linear relationship between the potentiometer's position and the output voltage, which translate to changes in loudness perceived by listeners. In a simulation set up using software like Multisim, you would connect a function generator to simulate an audio input signal and use an oscilloscope to observe changes in output as you adjust the potentiometer. By setting the potentiometer at different positions like 100%, 50%, and 0%, you would see corresponding changes in output voltage on the oscilloscope. This demonstrates that the potentiometer effectively controls volume by varying the amplitude of the signal without altering its frequency or quality. Thus, turning the volume knob directly affects how loud or soft the sound is from the speaker. That's all for question 1. Thank you.
Hi, my name is Intanor Afina and I will continue for question number 2. The root mean square voltage and the peak voltage differ because they represent different aspects of an AC waveform. Peak voltage, or more known as V-peak, is a maximum instantaneous voltage reached by the waveform, either positive or negative. For RMS voltage, or more known as VRMS, is a measure of the effective value of an alternating current or voltage. As you can see in the image, the blue sinusoidal curve represents the AC voltage, while the red dashed line represents the peak voltage. Meanwhile, the green dashed line represents the RMS voltage. So as you can see, there is a clear difference between RMS voltage and peak voltage. Thank you.
Assalamualaikum. My name is Nur Akila binti Zain Abidin. I will continue the presentation with the question 3, which is the controversial issue of the Beacon Dam in Sarawak. So, some of critics that argue that the Beacon Dam is economically impractical and environmental destructive. So, despite claim of the higher energy demands, indicate that Sarawak already produce more than enough electricity for their needs. So the next one is the dam construction has led their floating of the approximately 700 square kilometers of the rainforest and farmlands, displacing around 10,000 indigenous people from their external lands, primarily affected communities such as the Kenya and the Kayan and the Kenya 157. So the last one is the resettlement process for the displaced community has been fraught with issue, including inadequate compensation and the lack of the support for building their livelihoods.
Bismillahirrahmanirrahim. My name is Muhammad Iqbal Hafiz bin Zulkifli and I will present on the discussion of question 4. So the question asks to determine the half cycle average value of the voltage across R1 and R2 in figure 1, and all values are shown in RMS. As we can see, the R4 is connected parallel with combination of R2 and R3. Then the voltage will be the same. After subtract R4 and R3, we got 35 volt for R2. In step 2, we'll find the voltage in R1. After applying the KVL on outer loop of the circuit, we managed to get the value of voltage of R1, which is 55 volt. In step 3, we finally can find the half cycle average value since we have both voltage for R1 and R2. After we apply the formula of half cycle average value, we get the half cycle average value for R1 is 49.517 volt and for R2 is 31.51 volt. So to do the simulation in multisim, we need to find the resistance value for R3 and R4. So first, we need to find the current in R1 and R2. By applying the formula of V equals to IR, we'll get the current of 0.117 ampere for R1 and 0.035 ampere for R2. R3 and R2 are in series, thus the current is the same. Next, we subtract the I total with I1 and I3 to obtain I4. After we subtract it, we manage to get the current for R4, which is 0.047 ampere. And lastly, we use the V equals to IR formula to find the resistance value of R3 and R4. And we will get the value of ohm for R3, which is 857.14 ohm and 138.297 ohm for R4. After we did all the calculation, we finally can simulate the multisim with all the values that we receive. So that's all from me. Thank you.
V1, this represents a DC voltage source. It's labeled 1.699 volt, indicating it provides a voltage of 1.699 volts. This is the power source for the circuit. V2, this is another DC voltage source providing 24 volt. It is connected in series with V1. This means the voltage will add up. PR1, this appears to be a probe or a measurement point in the circuit. The value 35.987 volt next to it indicates the voltage at that point relative to the circuit ground, or V. So, for the ground, the horizontal line at the bottom, this is the reference point for voltage measurement in the circuit. It's considered to be at 0 volts. Because V1 and V2 are connected in series, their voltage add up in an ideal scenario. However, the probe PR1 is showing 35.987 volt. This is because the circuit simulation is likely taking into account the internal resistance of the voltage source and other factors which are not visible in the simplified diagram. So, the simulations show a simple series circuit with two voltage sources. The probe PR1 measures the total voltage at a point in the circuit relative to ground. The value measured is different than the simple addition of the two voltage because the simulation is likely more detailed than the simplified visual representation and accounts for internal resistance. Thank you.
The last part is for conclusion. Understanding the principle of electrical and electronic system is vital for advancing technology and solving real-world challenges. Components like potentiometers enable precise control in our system, while concepts such as RMS voltage and half-cycle average are fundamental to efficient power management and signal processing. This principle ensures the system design of reliable, high-performance system in varying from telecommunication to power electronic. Furthermore, the interaction between engineering, solution and societal impact as seen in projects like the Bakundam highlight the importance of balancing development with environmental and social consideration. By combining technical expertise with ethical responsibility, engineers can create innovative and sustainable solutions that benefit society while minimizing negative impact. This holistic approach is essential for addressing the complexities of modern engineering and infrastructure projects.